Hey guys, and welcome back. So let's take a look at the first approach to create debris, to create a debris source from the pieces when they separate. And let me drop the debris source quickly. You can see here, this is the default node in Houdini. It says the edge debris. This will place the edge points on the edge, and this will place points on the center. And this is the search radius to decide basically how far it looks for the neighbors. And from the first frame, it's going to store those neighbors, and then as they separate later on, the node is going to be able to check and compare how far those neighbors become, and based on that information, it's going to start changing the color of the points. Now you can definitely use this. This is a very good alternative, but I'm going to show my approach to use the edge detection method and emit from that. So let's drop down the transform pieces, and here I have let's see, transform. And here I have the geometry and the points. Okay, so let's connect the geo. Let's connect the points. And this is this is the original mesh I'm using, not from week 5, because I'm not gonna resim and recache everything. There's nothing different between what we've done and this. Everything is gonna be the same and should behave exactly the same. So let's go to a different frame, and as you can see here, we have pieces that are starting to separate, and then a lot of them that have separated. So what we want to do is we want to build a connection that stores the distance between all these. Okay, so we know this, we know where it was compared to this point, and then as they separate, we want to be able to tell that information. So this is very easy to do, and we don't need the entire geo for that. We're going to just use the inside faces. So I'm going to delete everything except the inside. And for the sake of speed, I'm going to isolate a set of points instead of everything, so it's faster for us to work with. Okay, and let's deform this. Cool. And what we want now is to keep only the edges of the geometry. We don't want the inside faces. So for that, I'm going to isolate one piece, and let's change this for the viewport to go back. I'm going to isolate one piece, and we're going to work with this first. So what I'm going to do is I'm going to group the outer edges, anything that is open, and I'm going to do that using a group node, and set it to edges, turn on edge method, and then unshared edges, and turn off the base. And this is going to give us the boundaries of the geometry. Okay, the next thing, we want to dissolve everything except those edges, so we're going to use a dissolve node, and let's call this edges. And this dissolve node is going to delete everything except those edges. Okay, and you can see now we have pardon me, we have deleted everything inside. It's just this one polygon, and I'm going to uncheck these options to only get to basically produce better result from this. And then the next thing is we're going to use an end node to convert all of that into edges, into primitives. So unroll and unroll here, and now we have a piece of geometry that we can use. Now there's a few floating points. I'm going to use an add node. It's not going to matter really, but I'm going to use an add node and remove points. Now we have this, which is fine, because it's not that simple to remove that piece. We could have gone with the outer geometry as well. So let's try the Okay, let me copy this. I want to do a quick test here. So let's try blasting this. This is going to give us a better information for the outside pieces, but we have a lot of things inside as well. So it's important to have a method that works with everything. I'm just testing this. I don't know if it's gonna work. Okay. Yeah, so this could give us the outer ring. See the geometry, I'm hitting the W now, it's just a ring outside. But this method is, if we isolate the outer layer, it's not going to give us everything we need on the inside. So it's better to use this and have extra edges versus using the outer information. Now, once we have this, we're going to use a resample node. And with this resample node, we're going to add points. Depends on how much we need. We want to subdivide this and add more points, something like that. Okay, and now we need to loop over each piece and do the same thing again. So we're going to use a for each named primitive, and we already have the name attribute. So let's do it here. So we already have the name attribute, and let's connect this, and let's take a look. Cool. So that's just the wire, and you can see we have data on the center, and that's going to be important as well for the inside emitter. Okay. So I've done this already, and I've cached the file. I've done it on the entire geo, and I'm going to create a file node, and let's read it in. And this is the result. If we click on the points view mode, you can see I have a lot of points between the edges. And now, one last thing we need. Once we converted these into points, we lost the name attribute. I think we didn't, but just in case, because the name attribute by default is a primitive, just make sure to, oh, I did this already. So here I'm promoting the name attribute, but if I haven't done this, we will lose the name attribute because we are just dealing with points at the end. So it's very important to keep the name attribute. It's still there. No, it's not. So it's very important to promote the name attribute, so it's at the point level, and that's already done. So now what we can do is we can use the transform pieces and transform all of this. Okay, and you can see we have edge connection. The edge is being transforming with the cache. Cool. So the next thing we want to do is we want to create a connection between all of this. So let's do that. I'm going to use the connect adjacent pieces node. I'm going to set this to 10 so it doesn't take too long to compute. And I'm going to delete, isolate some points. I don't want everything. Pardon me. Okay, so that's it, generated the connection. It looks the same because there's a lot of connection, and I'm gonna use the transform pieces on this, and you can see now we're getting this mess. Well, it looks like a mess, but it's actually the information that we need to isolate the pieces that separate it. Now what we have to do first is we need to measure everything at this point like we did before. So I'm gonna say I'm going to use a measure node, and I'm going to call this area before. Here the name area before, or area base. This is how long the primitives are, and I'm going to promote that into a point attribute. from primitive into points. Okay, and then we're gonna do the same thing again. So let's measure again, and area after, and we're gonna promote it again, and then we have two attributes. All I'm going to do is I'm gonna use a point VOP, and let's dive inside. Let's create a bind node. I'm gonna import both of them and compare the original against the new one. So area before, and let's subtract. And let's put down a fit range, and let's increase this to 10. Sorry, this one. And you can see now how it's working. Okay, so let's go here, and as soon as they start separating, we're gonna see them become white, and they're gonna stay like that forever. And this is something we don't want. Okay, we want to, let's set this to 1, so it's very aggressive. Anytime there's a difference, we're gonna see that changes to white. Okay, so we're using a 0 to 1. Let's set it to 10. And what I want to do is I'm going to use a ramp node. And I'm going to leave it at color. And right now we're not changing anything. But what I want to do is, once the points starts to change, I want to colorize them to be white, and then after that I want them to go to black. And we're going to do this with a ramp really easily. Let's go back. So I know this is a bit tricky, but basically we are only flagging them if they separate, let's say from 0 to 0.2, and that's it. That's the range we're using. Okay, or if the length if the measure difference is between 0 and 1, that's when we flag them. If they are getting extended longer or anything like that, we don't care. We're gonna delete them. And let me go back here and add an add node. I'm gonna tick on remove unused points. Delete geometry but keep points. And now if we hit play, now we're looking at points only. So if we hit play, we're gonna see them flicker and become white, and then dies off quickly. So that's basically what we want. And you can see it's even though there is a lot of geometry involved, it's very fast. And look at this area, for example, it's staying on here, it's staying on for too long. What we can do is we can go back in and lower this range so it's much sharper, much more aggressive, and then it's gonna flicker even faster. See? Only that range, and we can even squeeze it in to reduce how long the pieces, the edges are staying on. And so that's our emitter, and I'm going to use a blast node. Say add CD is less than 0.5, and I'm going to delete everything except those. And then if we hit play, that's our edge emitter. And we're gonna do one more thing to it in the next video to help. So right now it's staying on for too long. If the pieces have separated just a bit and they stayed like that, we don't want them to continuously emit even if they didn't change the distance. So we're gonna do a system that checks if the geometry is still on ahead. If it's on 2 frames ahead, we want to kill it. And this is something, it's a bit, I'll try to show it, hopefully it will make sense. But basically you have something that is moving from one position to the other, and then we're going to use time to check if it reached that position 2 frames ahead. If we get the answer yes, then we can change the current time. So this is called like a delta thing, where you offset the current state of things and then you compare them to the previous state, and based on that you find the difference. If the frame ahead is the same as the current one, we don't do any changes. If it changed, if it's different, then we do a change. So we'll take a look at that in the next video, and that's pretty much it for this one. Thank you guys for watching, and see you in a bit.